visible?
No, no, I will change that.
Okay.
Hello.
Hi.
A very warm good evening to one and all present here. Thank you so much for joining the event. Let me introduce myself. This is Gaurav Singh, founder and the event head of the Street community. I am very pleased to welcome those who have been with us for a long time and also to those who are new to the Dev Street community. So, I'm proud to host the event today at this wonderful occasion. Before we get started, I would like to express my sincere appreciation to all of you who generously helped us to make this event come together to become a successful one. I could not have done it without you all. Coming up to our event, Machine Learning, a Journey. This session will give you a brief information on machine learning. Let me introduce you all to the speaker of our event. He is none other than Ramansh Sharma. He is a lead machine learning engineer at Omenda. So, guys, no more confusions on machine learning because he will be telling you all about basics of machine learning, case studies from his experiences, a journey to Omdena, career opportunities, and much more, which would be beneficial for you all. Well, I don't want to take too much of his time. Today, it will be fun and full of learning. So, again, a very warm welcome to one and all. If you have any questions regarding machine learning, suggestion, clarification, or just want to say hi, you can find me and Ramansh in the lobby. Feel free anything to ask from us. Thank you very much for listening to me. With this, let's welcome our speaker for today, Ramansh Sharma. Hello, Ramansh.
Thank yes. Thank you, Gaurav, for the introduction. So, hi everyone. I'm Ramansh. So I'll start my presentation in a moment, but if any point during the presentation you get for some reason you guys can't, and I'm saying to the audience, you guys can't hear me for any reason, just put it down in the comments, and I think Gaurav or someone else from the team can let me know. And any questions you guys might have of the presentation or any topic, I have a dedicated Q&A session towards the and after the presentation ends, so we'll be taking all the questions that you guys have towards the end as well. So with that, let me start sharing my screen of the
Ramansh, I will
presentation.
interrupt you a bit.
Go ahead.
Uh, Guys, I would make it clear once that at the last of the event, we are having a quiz session. So, being tuned with us. Okay, Ramansh, you can carry on. Thank
Okay.
you.
All right. Thanks. Okay. So let me know if the screen is visible. And all right. So yeah, as Gaurav introduced my presentation as well. So I want to talk about machine learning careers and a journey today. So so this presentation will be oriented for more of for anyone actually, but more for beginners because I want to be able to explain to you guys how you can chart your own journey, chart your own path in this field after you start out in it, and how to even start out in it, and very very basics of what machine learning is, the best resources to get started with, some mistakes to look out for. So with that, let's get started. um, Yet another again brief introduction of myself. I'm Raman Sharma. Right now, I'm a machine learning engineer at Omdena, an AI for Good startup. I'll be talking about my work at Omdena a little bit in this presentation as well, so stay tuned for that. I'm also a sophomore at SRM Institute of Science and Technology. Many of you in the audience might know me from there. So let's get started. So today, so let's get started with what is AI and machine learning. If you didn't know about AI and machine learning before this presentation, I highly doubt that. But even if you didn't, you will go from here from with a preliminary knowledge of it. So, yeah, the most common definition of this field is in computer science, artificial intelligence, sometimes called machine learned intelligence, is intelligence. Okay, it's too long of a definition from Wikipedia. You don't need to. Yeah, it's mathematically accurate, but more of a definition which I personally like more is that AI is a field of computer science that deals with making computers smart. It's nothing more or nothing less than that. There are a lot of nuances and subfields within those subfields, and more algorithms than we can possibly count. But um, the general the general notion of machine learning is constant, that we're trying to mimic human intelligence into AI programs, into artificially computer programs. So what's not AI? You should always also know that what's not AI. So sometimes if you see any pictures like these, for example, like I actually see them a lot sometimes on, social media platforms or other groups, and I sometimes don't understand how and why these, blue circuitry, like sometimes mimicking human brain or human faces, represent AI in general, but you should understand that that's not really AI. AI is more like, it's supposed to solve business or societal or environmental or economic or medicinal problems using data that you already have. And in any machine learning algorithm, as long as it's supervised, but for most of them, yeah, you're trying to find a specific optimal solution to a very specific problem. And that's where you go from AI to machine learning. You go from a generic definition definition oriented field to more of a mathematical and computer science related field. And I really like this quote from Matt Veloso, who is, I believe he's I always forget his official title, but he's the chief technology scientist, or like he's the yeah, he basically suggests and supports to the CEO of Microsoft about the latest technologies and what should be the general vision of the company. I believe so. So I really like this quote that the nuance between AI and machine learning is that if it's in PowerPoint, it's AI. So something like what I'm doing right now, that's AI. If it's in Python, it's probably machine learning. So it's a little joke, but always remember that. Okay, so what is machine learning? We talked about what's not. Then let's talk about what is machine learning. It's a subfield of AI that deals with, creating models, creating programs that which we, very conveniently call models, that can predict an output based on previous examples it has learned from. Now, even if it's unsupervised learning, it still learns from previous examples that you showed. So that stays constant. Some examples of what machine learning can do: it can predict prices of not just houses, stocks, and clothes, but but of anything that you have data for. So, of course, you should always ask yourself, does my data really hold a causality problem? So um, and I believe that, yeah, so I'm sort of making it up on the spot, but um, I didn't want to just say that you can predict prices of anything that you have data for, because it's the core concept is that if you put garbage in, you get garbage out. So you should always know that you shouldn't force machine learning on a problem that's not suited to it, which is in the sense that if for some reason house prices were not dependent on features such as the area of the house, the number of bedrooms, the locality it is in, what if it's a private house or if it's a residential building. If it did not depend on those features, then even if you fit a good model, and even if your model can predict the price of an unseen house, of a before unseen house, that prediction won't necessarily be realistic in the world. So you should always know that what your features are and what you're trying to predict from those features have a direct causality with them. So, and some other examples are that machine learning can also recommend stuff to us. It can recommend movies, songs, books, shows, or products on Amazon, or anything else where you have data for it. So um, you can do a lot with recommender systems. For those of you who don't know, check out the Netflix challenge. I think that's what it's called, the Netflix challenge. That's a $1 million prize that once you become good at machine learning, you should definitely try it out with you and your teams. It's for recommender systems. So they'll give you a data set, and you're supposed to come up with a good way, and actually the best way, it's a competition to get a good accuracy in your recommended models. Machine learning has also very recently, and for some time now, made great advancements in medicine. We are able to now predict really fatal diseases early on in their development so that we can take preventive measures or um, take like medicinal measures to reduce the risk as much as possible, to reduce the effect as much as possible in a variety of diseases, not just cancer and diabetes, but a lot of other kinds, including COVID-19. And you can detect COVID-19 in a variety of ways, not just with chest X-rays, but also with CT scans. And I think it's in some cases it's better to use machine learning, but it's in some cases it's not. And that's how ML engineers and doctors communicate as to what would be the most efficient and the most accurate way to detect something that relates to a human life. Of course, we almost everyone knows about how machine learning and further so deep learning relates to images and computer vision. You can basically train a CNN, a convolutional neural network, on any image data set that you can possibly have, as long as it's either binary classification or multi-class classification, or even unsupervised learning. So you don't know what the label of those images are, and machine learning can still cluster them pretty well with clustering algorithms and other sorts that maybe I'll get into later on during the presentation. But very basic images, are the best friend of machine learning. You can do a lot with them. Okay, so moving on, I want to get started a bit on advice on how to get started in machine learning, and some mistakes to look out for, and some things you can focus on more than others. So let's get started with that. Okay, so the first advice that I like that I find important to give to beginners starting out in this field is that start simple. As much as we love playing around with neural networks of all sorts and even the most basic problems, don't start with them. They are hard to train. They are like hard in the sense they're computationally expensive to train. They're not the most straightforward to engineer and make in the code. So start simple, because the thing is that even in the industry, when you work with companies and you work with large data sets and production models, you still work with small models in the beginning. You never directly jump to neural networks, even if you're at the biggest ML lab in the world. So always start simple. And it's better because once you understand the core algorithms of smaller models, you'll be able to debug larger neural networks and more complicated models better than others who don't understand the basics. And that's really important. So start simple with something like linear regression or logistic regression, or a random forest classifier, or a tree-based machine learning model, and start with a data set that those models are more likely fitted to, such as house prices or wine prices. You can find any data set that you can possibly need on Kaggle or online on Google. So it's just that you need to find them and you need to get started with them. And I'll talk about more of how you can make your own project during this presentation. Another thing that goes without saying, but when you start learning, do not go for paid boot camps. Use free and on free online resources that are honestly much better, um, that I've at least personally seen, than any of the online paid boot camps that I've seen. That I've seen a lot of not a lot, but I've seen a few people who go for paid boot camps. That they sometimes come back to me and say they don't learn anything good enough or anything hands-on, even after a couple of months. So instead, start with online courses like the machine learning course from Stanford. I personally started with that like almost 2 years ago now. So I started with this field almost 2 years ago. So that's where I started, and those free online resources, take you into classical machine learning models, and don't skip over the math, which is really important, and which I'll emphasize more on later too. So never skip. So that's what they emphasize on, and that's really useful because you learn it in a progressive way, and you don't jump around between more complex ideas and less complex ideas, and then get confused on how to go from small things to big things. you go linearly, and that's why your foundational base of theory is really strong, and that's where you will be able to do better when you actually get to projects. So yeah, again, reiterating the same thing. Don't skip the basics, especially of math. I recently, actually, a friend told me that the math behind machine learning is just so much, it's so painful. But I'd like to say this. So it might look daunting in the beginning, but just bear with it, spend some time with it, and I can promise you that you don't have to become good at it over the night. Um, Take some time with it, take a couple of weeks to understand a big algorithm if you need to. But once you do understand the math behind it, you will be able to not only build up on it, hopefully in the future, to create new models, new algorithms, which will be helpful to the entire machine learning community, but also when you use high level libraries like TensorFlow or PyTorch or JAX, you'll be able to understand how they work beneath the hood, and as appropriately take actions to get the most efficient code that you can. And that's where matrix multiplication and linear algebra, and how gradient descent works, and how weight updates work in a model every epoch. So understanding the basic calculus behind that is also very useful. And if you can just stay with it a little while, it will give you good successful results in the near future. And another thing, so one note about online courses: don't just watch the online courses or any workshop for that matter. If there's a coding material in what you're watching, make sure to code alongside it at the same time. This is because you will learn what you're doing. So if you're watching someone code or explain something, that's what you're becoming good at. But if you code alongside them, you'll find the intrinsic, sometimes subtleties and some functions of libraries of how to play around with a data set, that sometimes just watching another person do it is not enough. So open a Jupyter notebook aside in a different tab, and then just watch your instructor, what he or she is coding, and then replicate it, and then make sure you get the same results. And even better, experiment more yourself. So the crux of becoming a good researcher, a good practitioner in the computer science field, not just machine learning, is experimentation. You should feel confident. Actually, you should be excited about, not just comfortable with, change and sometimes uncertainty, because and you should not be super afraid of errors. You'll face a lot of errors in this field, so just be prepared to handle them, and experiment a lot with the code that you're doing, even while the online courses are going on. So some time ago, I watched this. Actually, not I say some time ago, but it's been more than a year. Um, that I watched this amazing online event from where a prominent Turkish researcher, Dr. Utku Kose, was speaking, and I liked some of the suggestions he gave. So I wanted to share some of them here. So learning about the philosophy of AI and its essentials is super important. I've seen, and everyone does it, but and it's okay that some we when we start, we want to learn about the math behind it, the models, how to train on data set, how to do inference, even how to productionize the model and host it over the web. That's cool. But eventually, when you get to larger teams, you'll want to know about the conception of machine learning models and how they came about to be. And that's where the philosophy of AI comes in. Why did researchers in the 70s and 80s come up with gradient descent and come up with ways to mimic the human training system, human learning system? What benefit does it do? And if the problem that you're solving today right now with your team can take some hint from that, how can we approach it from a different perspectives? So and yeah, what I'm saying right now might not sound very specific, and it's for a good reason, because this is very um, abstract and generic. But when it comes down to a specific thing, you'll know what I'm talking about when you know the philosophy of AI and some other things. So you don't have to explicitly study them, but you should be aware of it. And if you're curious, don't just put it on the back of your mind. Google about it and learn about it. So learn about the algorithmic details of AI techniques. Yeah, I just spoke about this. Starting with smaller models is important because you get to learn about like sort of take apart the model brick by brick and understand what's going on beneath the hood before you not just put them together, but take 100 other things and build a large neural network. So yeah, write scratch code first. Do not use the libraries directly. This is probably the most important advice that I can impart on you today. If you're starting out, or if you have started out and you're using TensorFlow or PyTorch or Julia or Jamspell, or sorry, not Jamspell, Jax. Sorry, I don't know why I said that. So if you're using a high-level library, you might end up, and if you haven't implemented the large networks yourself before, you might end up with some problems later on. When you work on a larger project with a larger team, you need to be able to explain what the model is doing, because AI explainability is a really important thing that is very important. And if you're starting out, make sure to not skip it, because that's an important aspect of good machine learning engineering. So how can you become better at AI explainability? Well, you should be able to understand your models really well. How do you do that? Not just learning about them or taking notes, but implementing them. So before using TensorFlow to build your first neural network in 5 lines of code, make sure that you can do it yourself from scratch. And that's why online courses are super helpful, because more often than not, at least the ones that I'll be talking about today, they go from scratch. So you'll be implementing every activation function. You'll be implementing the back propagation from scratch, and you'll be making all your forward functions and backward functions over many layers, and you'll understand how everything fits together and appreciate the neural network for sometimes the large entity that it is. So make sure to not skip over that. Yeah, learn about some supportive technologies. I'll mention this a bit later, but this is about how machine learning has some good tools that you can make use of. Learn about data science and statistics. So the math behind it is really important, and it's a very fine line between machine learning and data science in the real world, actually. So it all depends on the scope of the project that you're working on and the use case of the project. But you should know, when you speak to other people, as to if your project is more of deep learning research, or if it's more of an AI for good data science project. So you should know the nuances of those. Yeah, spoke about the mathematics and the core logic of machine learning. Choose Yeah, you don't need to choose subfield while you're starting out, but what's really important is to join events and training programs and online courses, because yeah, more importantly, join events, because before you actually start working on big projects, it'll be helpful for you if you can get started with some machine learning communities. And believe it or not, you actually learn a lot, technically speaking, and even non-technically speaking, from these communities, as to not only to how to host events, how to contribute to events, and learn about researchers and practitioners from around the world, but also you also get opportunities in machine learning, internships, or sometimes even full-time roles. So make sure to join communities, and I'll mention some good ones that I have benefited a lot from in this presentation. Reading research papers is also super important, and you can find the latest papers sometimes on archive, sometimes, more often than not, believe it or not, on Twitter. So sometimes the latest advancement in machine learning appear on Twitter before they do in a newsletter or even on Reddit. So you can make sure to follow some famous scientists, your favorite scientists, on Twitter. So I think, yeah, one thing before I get into interesting projects that I have worked on, one really important thing. So make sure that when you are doing online courses, you're taking handwritten notes. I always say this because it's yeah, the other advice that I said is the most important. This is probably almost actually as equal in importance as that. When you take handwritten notes, the retention of your material increases a lot. And in machine learning, where we work a lot with math and statistics and calculus and linear algebra in combination with code and conceptual understanding, taking notes is a lifesaver. Not just to Because when an instructor is teaching something over an online course, more often than not, they're trying to find the best way to teach a lot of students. But and that's a very good approach. But in order to make the learning material as useful as it can be to yourself, you should personalize it by taking your own notes in any way you find understandable. Take like side notes, or if you only take down things that you find important, and it's going to be really helpful, because if you keep all your notes in one place, then then at a given later point in time, if you're preparing for an interview, or if you just want to revise, I don't want to say revise, but like just look back to a concept that you're not really sure you remember anymore, say you don't remember how capsule networks work, then just flip back to the place where you took notes for capsule network, and just learn about, and you'll find that you can understand your notes because you took them. So that's really important. So make sure you do that. Now let's get started with some interesting projects that I'm working on, and this is my favorite part of the presentation, because I get to talk about a very interesting project. And the first one, excuse me one second. Sorry about that. So the first one that I want to talk about is predicting illegal dump sites. So this was a community group project that I participated in with Omenda, and it was in partnership with the Trash Out NGO. It's an NGO in Europe, based in Europe. So Omenda partnered with Trash Out, and they brought together 35 data scientists from around the world to not really solve the problem of illegal dumping, but work towards creating some solutions that could mitigate illegal dumping around the world. So so I want to talk a bit about this community project that I was a part of. Okay, so let's get started with it. So let's start. So I'm going to take you through the perspective of how we went through the project. So this was a 2-month project. So I'll take you through the perspective of some of the problems that we faced and how we overcame them. It's not going to be super long, but I hope you enjoyed that. So, and by the way, all the images that I'm showing here are part from the blog on this project that was written at Omenda. So if you just search about Omenda Trash Out Illegal Dumping, then you should be able to find this blog online. So
Ramansh, we
let's
have
start with
some
the
questions here. Sorry to interrupt.
okay.
You can
Okay.
answer to that. Yeah.
Okay. Let me just look at that.
Okay.
Okay. Okay. These are amazing questions, but I'm just going to finish the presentation for time's sake, and then I'm going to answer every single one of them. I promise.
Okay, Ramansh.
Okay. So let's just So I want to continue with that. So some of the data sets that we had, that we needed to work with. So first of all, Trash Out very helpfully gave us a good amount of data set on the on the dump sites that they had recorded on their mobile app. And by the way, you should definitely check out the Trash Out app. It's a very cool it's a very cool app like Pokemon Go, where you can when you're walking around, you can take a picture of an illegal dump site that you can find, and it will just show on the map, on a worldwide map, and you can host community cleaning groups. So it's your part in making our world a cleaner place. So we had around 50,000 dump sites that Trash Out recorded, and it had many features like latitude, longitude, the city, country, continent, the date, picture, size, and type of waste. So by the way, this thing that I'm talking about right now is one part of 3 major tasks that the whole project was working on. So the thing I'm talking about is trying to come up with a model that can predict the possibility of a land location anywhere in the world becoming a potential illegal dump site. So basically, yeah, a classification model of sorts, if you will. And there were other tasks in the project which were working of a more computer vision basis. That task was working with, what if you take a picture of a given piece of trash, will you be able to classify it into the correct sort of trash? Is it biological waste, radioactive waste? I hope it's not radioactive waste. Glass waste, or like other kinds of waste as well. So I'm talking about the task that I was contributing to, which was to predict the possibility of an illegal dump site appearing on a given piece of, not piece, but a given location. So we had dump sites. What else did we have? Well, so we had dump sites. Now we needed more data set, because part of the brainstorming that we were doing in the initial part was analyzing the data we had. And actually, yeah, let me show you this first before I go back to that earlier slide. I should have rearranged them better. But we were trying to understand patterns in the dump site data set that we had. Like, is the size of the dump site something that we can include in our prediction, like sort of have an ensemble model? Or is the location of the dump site really significant to that place becoming a dump site or not? Of course, those things are important. Location is important, but we figured out that the size of the dump site is, of course, a good addition that hopefully the future version of the machine learning model can have. But at that time, we were more focused on detecting a dump site in general, regardless of the size and the type of trash, actually. So but how do we do that in the first place? Not just with location, that's not good enough. We needed other things. So we came up with, we brainstormed, our whole team brainstormed on what factors, environmental and societal factors, affect a location to become prone to becoming an illegal dump site. So we came up with several things. First, the distance to the road. And actually I'll show this to you more later on, but the distance to the road turned out to be a very important feature. And what did we did? We found a good API that could help us find the distance to road information, not just one road, but like big road and small road, from a given location anywhere. So we had the distance to road, nearest road, information from the OpenStreetMaps API. Then we also had the population density. So we also needed, because we figured out that a largely populated area is more likely to, you know, be at a risk of becoming a dump site than a less populated area, because you just have more people, and that likely contributes to a larger amount of trash. So we use the CTAC data set. I believe this is maintained by NASA. I'm not sure, but I remember NASA was affiliated with the data set, and it was super helpful because that data set gave us the population of 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 every 1 kilometer 1 kilometer squared cell on the face of the planet. So that was a very large data set, and we were working on Colab and Google Drive. So you can imagine the difficulty we had with working with a several, actually like a several gigabyte size data set on Google Drive. But it was, we were able to store it in an efficient manner and use it in an efficient manner. So we also needed to actually calculate something called the population gradient. So we figured out that just having the population density of the 1 kilometer squared cell where the dump site is not necessarily enough information about the population. There's a likely case that the 1 kilometer squared cell around that dump site might also affect that, might also contribute towards that dump site being there. So what we did was we created sort of a gradient of those populations as well. And we also we had to make sure that any of these cells were not lying in a water body. So we also needed to work on that. Of course, then another important feature that we found was useful was nearby venues and what kind of venues there are. So like venue categories and the number of venues and the average distance to them, and um, and these are like categorical features of the most frequent venue categories. As you can see, venues were really important. They contributed a lot, not as much as individually speaking, but together they were important. So we used the Foursquare API to find information on that. And that included, so yeah, we had a lot of information about venues such as whether a given location is closer to a restaurant or a public gym or a park or a soccer ground or a swimming pool, which likely attract large numbers of people and might contribute to more trash. So we another part of the whole project was actually giving a very strong analysis of the analysis on illegal dump site around the world, and a lot of socioeconomic factors from World Bank indicators helped us in making that. Now I'll talk about non-dump sites in a moment, but keep that in the back of your heads. Non-dump sites were very a pivotal part of the project. So those were the data sets that we worked with, and this was just an example of data analysis that we performed. But let's come to the pivotal point, and I really like this part. So in order to teach a machine learning model, as to what's a dump site, we also needed to learn what's not a dump site. Because unlike us, where if I show you a picture of a cat, you'll know what's not a cat. But to a machine learning model, you need, even for a binary classification, you need two classes. And there are approaches such as zero-shot learning, but I believe they're more useful in computer vision tasks than in more of a numerical and categorical feature use case. So how did we solve this? So what we did was uh, created our own control data set, because we didn't have non-dump set, but we had to make sure of a lot of things when we did that. So what we decided was that you cannot just say that that a single location that's not a dump site is a non-dump site for all the dump sites that we have. It needed to be a pair. So for every dump site, there needed to be a non-dump site. That was one thing. So what we decided was that, okay, so if you have a dump site in a given location, you're not likely to have another dump site in a short radius around it. The larger radius you have, yes, the more likely you are to you know um, encounter another dump site. So that was the first part that we tried to like narrow down towards finding our control data set. So what we did was that we experimented a lot with the radius that we need to go from a dump site to find a non-dump site, and we eventually found out that 1 kilometer was an optimal place, like optimal radius. Now you might ask me, why didn't we just pick the shortest radius possible, because that's the most confident area where we won't encounter another dump site? Well, the reason was because the points needed to be not too close, so that the model, because if it's too close, the model will fail to realize the key differences between the features that I talked about 2 slides ago, between the dump site and the non-dump site, because they'll be within the same population gradient area, the same density area, and the same venue category. So it needs to differentiate between the two classes based on those features. So it needed to be have at a safe distance away, but the distance needed to be close also, not too far apart, so that the model won't be able to figure out the subtle changes between the venue categories, the distance to road, the population density, the number of venue categories between the two classes, the points, actually, not classes. Well, in general classes, but between the 2 points, that was really important. So, uh, so those were some important things. And also, what we did was that we picked a pseudo-random point on the circumference to pick the non-dump site for a given dump site. But we also needed to make sure that the point did not fall into a major water body. So that was another important thing that we needed to do. And we were able to accomplish that, and we now had a control data set. So we worked with a lot of models, and let's put this away. Okay, so we worked with a lot of models. Not a lot, actually. We worked with, first we started with random forest classifiers, but turns out that it wasn't fitting the data set well enough. Then we spent a given amount of time on neural networks. I actually did that myself for some time, but they weren't. But the test accuracy was not good enough with neural networks. It was too low. The training and validation were fine, but test was not good enough. So it was not generalizing well to be used in production and in the real world, which this model was going to be. So I think I should pace myself. Well, I'm taking too long, but yeah. So eventually we ended up with a light gradient boosted model, a tree-based model. So another lesson to take away is that sometimes even in big projects, in real world productionized models, you don't work with neural networks, you work with classical machine learning problems, especially when your data set is more of a numerical and categorical mix-up of features rather than an image or text. In those cases, you will likely not work with classical machine learning models. What I'm showing you on the screen right now is the importance of those features that we talked about earlier. This is called a Shapley plot, Shapley. Okay, I don't know, which tells you how much will the sort of the accuracy of the model change if you modify a given feature. So as you can see, distance to road was the most important one, since it would have the largest impact on the output. So that turned out to be this was a useful analysis for Treasure because they could use this when trying to mitigate illegal dumping. So what our final product was a heat map. Not one heat map, but the ability to make a heat map for a given location. And you can guess why this was so useful. Apart from just being on so this was for the city of Bratislava, which was our model city throughout the project. And as you can see, the more red portions of the heat map, indicate a larger probability of the location becoming a potential dump site than the yellower regions. And as you can see, it's not perfect, which it should not be because this model needed to generalize for the entire world, not just one city. Of course, the model can be retrained very easily for one city, and which might give you more confident values. But even for the entire world, our test accuracy was 84%, which was pretty novel considering this was the first time machine learning was used to attack illegal dumping. So this was useful because what TriShot can now do is that use this to warn and discuss with local municipalities and authorities on how to target those neighborhoods within a certain place where there's a larger likelihood of a potential dump site occurring over there. So that was a bit about the Trash Out project, the community project that I worked on with Omtena. So let me continue, and I'll take any question you guys have about that project later on. But let me continue the project, presentation right now. So yeah, another interesting project that I worked on in like March 2020 was a flight price estimator. So that was the largest data set at that time that I had worked with, which was, it had 9 million flights and a lot of numerical and categorical features. So sort of a classical machine learning problem, but the mistake I made was that I tried to fit a neural network to that data set. And as you can guess, it did not turn out really well. So my accuracy was super bad. So this is a neural network that was taking in categorical features and numerical features, and despite a lot of articles that told me it will work well, neural networks will be able to work well, and they can with more effort and probably a better approach in the first place, they will work well. But what could I have done better? I could have picked a smaller model to work with. There's no shame in working with classical ML models. Those are strong to their core, more predictable, and they work better when you have categorical features, especially categorical features. So my accuracy was so bad; it was 46% with an epsilon of $70. So even when the magnitude of the flight prices was like $200, $300, $400, even with a large epsilon, like a plus minus $70 range, my accuracy was pretty bad. So in retrospect, I could have worked with a smaller model and probably saved myself some time. Another project that I worked on even before the flight estimator project was alternate reality. So when I was first learning about recurrent neural networks, basic NLP, I really liked text generation. So what I did, I made a unidirectional recurrent neural network, and I gave it some essays, homeworks, poems, and research papers in history that I had written in high school to the recurrent neural network, and it was able to generate text character by character in my style. This was the first 400 characters that my model wrote, and as you can see, it's not that good because when you have a character level RNN, you will have a lot of spelling mistakes. Of course, you can reduce these spelling mistakes by trading the temperature of the model to the novelty of the model. So the temperature of a model like this is basically so what's your trade-off between better accuracy, so less spelling mistakes, to more newer words. So I wanted to be like keep it a good ratio. So I don't mind small mistakes, but as you can see, some of these are not small mistakes, but I also wanted a variety of words. So, and considering that it's doing it one letter at a time, so it puts R here, then it looks at the entire text again, and then puts an E, and then it's still able to understand basic punctuation, numbers, like subject work agreement pretty well. It's still interesting to see how the model turned out. Of course, in retrospect, I could have done it bidirectionally, which at the time I was figuring out some nuances with the TensorFlow API. So I wasn't able to do it that time. But so this is another interesting project that I said that I worked on. There are other projects that I'm working on right now that unfortunately I'm not allowed to put in the presentation. But For example, I'm working on another project on behalf of Omenda with the World Resources Institute, which is super cool. We're working on policy analysis of land restoration in a lot of countries around the world. And since our use cases related to NLP, we are fortunately able to get the GPT-3 API. So it's very interesting to work with large networks like this. And that's what happens when you stay in this field for some time. When you work hard, you'll be able to get on big, interesting projects like that. So let me give you a couple of things to make sure on when you start working on personal projects. First of all, make a plan, at least in your mind, if not on paper. It's better to have it on paper. Um, Try to know exactly what you're trying to accomplish from this part. And this is a big project, not just a Coursera notebook that you're working on in an online course. Those are not projects. So when you have a data set, if you already have the data set, begin cleaning and analyzing it. If you don't have one, get one from online, either from Kaggle or online data set. So you'll be able to find the data set in any field, in aviation, in medicine, in geography, satellite imagery, any of the data sets that you want. You'll probably find many interesting ones in probably TensorFlow itself. Like you can import it through TensorFlow, but you can find it online as well. So get your data set first, and then know what you're trying to accomplish with that data set. You will spend, if this project is good, like complex, you'll spend at least a week and a half on cleaning and analyzing data set, which strictly includes visualization. I've seen a lot of people, including myself, and sometimes we just try to sneak out of visualization because it's hard to sometimes make good graphs that are useful to understand anything about the data set. But don't cheap out on it. It's important, and you'll do a lot of visualization in large projects. So that's important. And try to ask yourself, do you even need machine learning for your problem? And you should always be honest. If you don't need machine learning, never force it on a data set. Garbage in, garbage out. If there's nothing to learn from your data set, you'll only be wasting your time, and it will be everything that your model gives will be a false positive or a false negative. If there's no causality between your features and your output. So understand it from a non-technical perspective. Does it make sense to use machine learning? And of course, analyzing and cleaning the data set. I've seen a lot of people that just jump into modeling. Never just jump into modeling. The first thing that you should do is analyzing your data set as much as you can, or at least enough so that you have an idea of what you're trying to do with that. That includes visualization, but it also includes seeing, are there any null values or NaN values in your data set? Are there any like columns that you better drop? And you sometimes understand them from visualizations of correlation. If you have a classical model, classical machine learning data set, use feature correlation to understand if some features might not be useful to have. For example, in the threshold data set, the date was not that useful because the chronology of dump sites was evenly distributed. We didn't need the date, so we dropped it. So you'll understand which columns to drop and which to keep, and sometimes to combine. And that's for another time, but keep that on the back of your mind. Try simple models first. Never start with neural network. If you can do well with a linear regression or random forest classifier, don't unnecessarily increase the complexity. That won't be useful. If you have 98% accuracy in all sorts, not just binary classification, with linear regression, why would you want to go to a neural network, right? Deploy your linear regression model. That's good. And understanding when to stop is a very underrated skill in this field. So always know that. Sorry, one second. Excuse me. So yeah, I think I wanted to mention one more thing. If you start with simple models and you're doing bad in your simple models, there could, of course, be the case that that could be because your model is not big, complex enough to, represent your data set. But if your problem is linear regression, and your linear regression model, like I'm talking about from scikit-learn, like a classical model, is doing 20% accuracy, then there's likely a case that you misunderstood your data set because there's no, even if you think that you're able to represent it linearly, then there's some bug going on in your data set, or you haven't understood the scale of your variables. many variable. It could be multivariable linear regression, but you need to spend more time with your data set if that's happening. Going to a bigger model won't help you in that case. Visualize your model's performance, not just the training and validation accuracies, but AI explainability is really important these days. Make shapely plots, and they're not eternally hard to make. Spend some time with it, and you'll be able to understand if your model is doing well and what should you. Sometimes you go back and change your data set after making a small model first. So you will understand how to modify your data set or how to modify your parameters, hyperparameters, training style, whether you need a GPU on Colab or not. And what's your trade-off? If it's not a straightforward problem, you should understand your bias variance trade-off and how you must deal with it, and be able to explain it well in your documentation. Coming to the documentation part, write an end user script to let others make use of your machine learning model. Host it on GitHub. I think that went without saying, but you should host your models and your all the scripts and the code that you've written on GitHub. And write an end user script. People don't want to find where and which function in 10 different Python files to run in order to train and produce results from an ML model. Right? And when I say an end user script, make a separate script that calls on the different functions, and you show an example of the code that you need to run in that end user script in the README, so people know what to run in the file that they need to go to. So if you're now about doing more than just training a model, if your model is novel, it's never been worked on before, you'll be able to find those, by the way, pretty easily with some good amount of thinking. Write a Python package for it. Let others install, like pip install your package, and use your machine learning model in that sense. If it's not novel, it's not an excuse to stop there. Host it on a free hosting service. If you want, try Heroku first. Heroku is so fast, we can deploy a model on that in 10 minutes. Or if you want more customized, more options to customize it better, use AWS. It will take some time for you to learn them, but it's not hard to use AWS. Document your experiment well. Write a full-fledged markdown documentation on GitHub. And let others understand everything, every decision that you made. Why did you make it? How can you improve it? How, in not just one way, in 10 different ways. And spend some time with documentation. People read the README before they go into the code. So applying for internships or jobs, and I'm just pacing myself a little bit because I don't know, I'm running out of time. So make a habit of keeping your LinkedIn profile up to date. That's super important. You'll find some of the best opportunities you will in machine learning over on LinkedIn. So talk about and when you keep your profiles like good enough, like if you spend some time on it, you learn how to talk and write about your technical and non-technical experiences in a professional manner. That's very useful when it comes to applying later on. And the thing about applying is that the only way to become good at online applications to internships and part-time roles or full-time roles is to do it a lot. And the more you do it, the better you become at answering some fundamental questions like why should they pick you? How will you be able to make yourself useful with your skills and your experience and your communication to this company or to this project or to this community? How will you help others, and what do you hope to learn? What do you have to gain from it? So some of these answers are not always straightforward, but they take some time to reflect upon, and you'll become better at it if you apply a lot. And turn on basic internship alerts on LinkedIn. You'll get a notification on your email or your phone when machine learning internships are over there. Some other company has posted them. You can reach out to recruiters over LinkedIn as well. You'll, out of the 8 to 10 cold messages that you send them, you'll get at least one back, and you'll be able to understand them. And you should, of course, send more than just 8 to 10 cold messages. Keep your pitch short. Don't write more than 5 lines. Sometimes we feel that if we don't write enough, the person will think that we're not serious about the position, or we're just underestimating the importance of it. But that's not the case. So I used to make the same mistake, but it's okay to just be to the point. Just introduce yourself and where you're studying, what position you're at right now at a company, if you're at a company, and what kind of help would you be really what kind of help would you really appreciate having from that person, not just a recruiter, but from a person at the company. If you want a referral, or if you want to be connected to someone at the company. So like in that sense. Um, yeah, okay. So you'll have this access to the presentation later on. So I'll just move on. But yeah, always be prepared to talk about your past projects in detail. Don't violate your IP contract. That's never good. But be prepared to talk about them in detail as much as you can. So continue. Okay, let's talk more about job internships and jobs. So before you actually just start applying, consider joining a machine learning community that can help you get started with resources, projects and internships. And the first one that comes to my mind that I personally benefited a lot from is the deep learning AI community. In addition to making world-class online courses that honestly teach you everything that you need to know to get started in this field and get even a good internship, or make good projects for the very least, is that they have communities. So for those of you who didn't know, for example, the NLP specialization of deep learning AI has its own dedicated Slack group on Slack, where all the learners around the world who have joined that specialization can be there. Many are there already. I think it's at least hundreds, if not thousands, where they're talking about a lot of different ideas in NLP. If you're stuck on a coding problem from the online course, how can you discuss it and solve it? More importantly, if you want to connect to other people, collaborate with them, and you can make projects with them and learn from each other. If you might see someone solving a bug in a different way than you probably had considered, and that's learning. That's a step towards becoming better in training, not just training, but like in machine learning engineering in general. More importantly, if you want to be connected to opportunities, there are a lot of recruiters and people offering collaborations in research labs or in companies or in those Slack groups. So consider joining them. They're really useful. Another one that I find really useful are Pioneer chapters. So Pioneer chapters are events hosted by deep learning AI ambassadors. For example, I host one that I think will go a bit about 1 hour, but I think that's okay. I'm approaching the end. So yeah, Pioneer chapters are like deep learning AI ambassador events. They're around the world, and when I joined, it was smaller, but now they're really spread out around the world. And these events are in a conversation with experts and industry leaders, and I'll talk about one of them right now. But you can join them. You can send an email to. You can find it on the website and just get started. Become a deep learning AI ambassador, and then host events in your local community. You'll find it's so much fun to collaborate with ambassadors around the world. Some of my mentors and my collaborators are in Kenya, and I've hosted so many events over the past year with them, and I still am considering hosting more events this year. And it's just amazing. It's just an amazing experience. For example, I collaborated with my friends from India and Kenya to host a NeurIPS meetup. So NeurIPS is a worldwide, actually not a, like an annual machine learning conference, and they allowed local chapter meetup. So we hosted Pi in AI Nairobi, the 2020 meetup, and just look at the speaker array that we had. So you can gain this kind of experience when you collaborate with other, ambassadors and other event hosts, and just gain more from the community. Of course, there's also a Slack group over there where you can connect with a lot of other learners from around the world and just not just talk about events, but talk about anything in general about the future of machine learning and what you can do. So this was a great event that was hosted in December 2020. If you search Pioneer Nairobi 2020 meetup, you'll find the YouTube of this event. So as you can see, we had Stanford University PhD candidates, people from Facebook, Amazon, senior research scientists at Spotify, and Arno Pretorius was our keynote speaker. He's actually the only African researcher to have 2 papers accepted at NeurIPS in 2020. And just listening to him in the live event was great. And we also had an amazing Women Shaping the Future of AI workshop within the event. I think our event was pretty long. It was like more than 4 hours. And this workshop was super cool because our female speakers were talking about, how to engage more women in this field, how to, encourage them to get started, and talking about some accomplishments from organizations such as Women in Machine Learning and Data Science and other such places. So it was really great to hear from them on that topic. So there's a lot of communities that you can be a part of. This is I think I'll just skip past this, but this is a really cool one. This is hosted by it's not an event community, but Data Mean is hosted by Abhishek Thakur, the first 4-time Kaggle Grandmaster. I believe I said that right. And it's really useful. You can learn from other people in Data Muni and host and write awesome technical articles. If you just check some of these out online, you'll find what I'm talking about. They're so interesting. So another one that I really wanted to talk about, of course, is Omdena. So I would like encourage you in the audience to consider applying for an Omdena project. Why am I saying this? Because they give you a lot of technical experience, increase your communication skills, and allow you to work with data scientists from around the world on an AI for Good project. Some of the previous projects that Umdana has worked with are in collaboration with NASA, World Resources Institute, Crash Out, Red Cross Foundation, and a lot of other partners, which you can find on the website. But more importantly, these projects, are so intense. For example, one project worked with the aftermath management of earthquakes, and many projects have worked with quality worldwide satellite imagery. There was one project which like processed 700,000 PDF within 14 hours. Can you believe that? That's so much for an NLP use case. There have been damage assessment of desert locusts, child and sexual abuse in developing countries, climate change and climate hazards, predicting wildfires, disaster response, malaria prevention, rooftop solar panel rooftop solar panel estimation. The rooftop solar panel project was so interesting because with just an image from Google satellite imagery, you can figure out in the exact amount of energy a house, a top of a building, a roof can generate with having solar panels. And the project was so interesting because it also found the difference between obstacles on the surface of the roof and the labeling part of the project was done within the project by the collaborators themselves. So you get to work on a variety of topics, and it's super interesting to work on them. If you want to learn more about those projects and would like to discuss it with me more later on, please reach out to me over LinkedIn later on. So coming towards the end of the presentation, why should you choose machine learning? Why should you work in machine learning? So my advice is don't do machine learning for the sake of it. In addition to like what I told you earlier on, that don't force machine learning on a data set that does not make sense to be used in an AI aspect, why should you choose machine learning? So for example, does anyone in the audience know what this neural network is? What model do I have on the screen right now? So I'll just swipe to see. Okay, so like if you want, just put it down in the YouTube comment, and I'll just wait for 10 seconds. But yeah, I'll just say, but I just want to know if anyone has heard of it before. Okay, so not a problem. So let me just continue. So this is a vision transformer. So it's actually my favorite neural network that I have ever seen. Actually, I have yet to work with it, but it's my favorite neural network because it's so inspirational. So some time ago, I was trying to understand myself. Does it make sense to why haven't researchers found more sequential models on images before? They have, but not as much as they have found sequential relationships in text. So like images have spatial features, text has sequential features, music has sequential features, but images don't have sequential features, at least not intensively. So why haven't people worked on it before? So I thought, the reason why it might not have been done before at that extent is because we haven't found, because we apply a sequential model on the entire image all at once, at least in many experiments. But it would be more useful to find it in a localized patch of an image, just like we use a CNN using the sliding window algorithm on a localized part of the image. And I was going to do some, like shallow experiments with recurrent neural network, but then I found this paper from Google research team that was accepted at iClair last December. So I think last December, like in 2020. So this is super interesting because it talks about, this paper is super interesting. Check it out if you would like to learn more about this. So I was really interested in it, and I'm still going to do more experiments with it because I find this super interesting personally. But so what more did I do with it? So when I read the paper, I didn't understand it at first because it was very hard to understand, at least for me, because it was it was just hard to understand. When you open the paper, you'll see what I'm talking about. But I stayed with it, and after many days, I was able to make complete sense of it. And sometimes, if I open the paper right now and I find something I'm not sure I remember what I understood from it, I'll just spend some time, 5, 10 minutes, and I'll be able to understand it. Might take 15 minutes to me, might take a little bit more time or less time for some of you guys, but that's okay. If you stick to it, you might be able to understand some of the complex ideas that novel research papers are talking about. So some, for example, you might understand that MLP is multi-layer perceptron, and this is layer normalization, but you might not understand what MSA is. And I should be able to tell you what MSA is, but I'm not sure. I'm entirely sure right now. So okay, it's right here. Sorry, multi-headed self-attention. So yeah, transformer models, they use self-attention and multi-headed self-attention actually. So when you so first time you read a paper, a complex paper like this, you might not be entirely sure what it means, what's the overall idea, but you don't always have to understand every single line of a paper to understand the whole gist of it. And I wouldn't say, but like more like the idea of it, and why did the authors did what they did, and what kind of problem were they trying to solve, what was their solution, drawbacks, future advancements. All great papers always talk about that. So reading research papers is a big part of machine learning, whether you're in the industry or research, a student, or a professor. So be prepared to read research papers. So this is not for me to discourage you from reading papers or from joining machine learning. Far from it. I'm just saying that you should be, prepared to work hard in this field, because in order to become good in this field, it takes time and a lot of effort on your end to understand not just one thing, but a variety of things. So, and you'll be able to find interest in doing that if you enjoy it. So I'm saying that don't do machine learning for the sake of it, but choose machine learning because you find it inspiring. Ponder the big questions that why, how can we, approach better how can we make newer models that are not just trying to increase 1 or 2% accuracies at the end, just from previous papers, but try to understand, try to, think about how can we make models that mimic the human learning process, because those haven't been found so far. You know, um, like great researchers like Dr. Jeffrey Hinton talk about them in a more philosophical and from a psychologist perspective. And you should check it out. So cross-discipline research is the best thing that can happen. And you can talk about things like, how to find more complex things like stack up restricted Boltzmann machines to have a sort of an active loop from your hidden layers back to the input layer, the same input layer, not a new layer. So try to play around with a lot of things. Don't be afraid of errors at all. Having errors in machine learning means that you're learning, means that you're growing. If you never hit any errors, you haven't tried anything new. So like how Einstein said, if you haven't like learned any, yeah. So okay, so don't be scared of errors. You'll face them a lot, but just try to. You'll find some. You'll always find help online on online forums. So be sure of that. I always like to end with this quote: "The key is not success; it is to fail expensively and learn from it." So be like a neural network. Neural networks do that. They're not good in the beginning, but they learn from it, and they learn from a little by little every time, and they become very good. So be like neural networks. Um, don't be afraid of being not so great at the beginning, but be sure that once you start learning and putting in the hard work, you'll become really good in this field. So that was it for my presentation. So for those of you who would like to go through this presentation later on yourself, this is the link to these presentations, bit.ly machine learning careers. And I would really appreciate feedback from the audience on this link. If you go to slido.com/ML careers, you'll find 3 questions there. Just help me, improve my presentation next time for a future conference, or like a future event. So I would really appreciate that. So thank you so much to the DevStreet team and to the amazing audience that is there on YouTube today. So let me get to the Q&A question. So I'll stop sharing my screen. Okay. Okay, so so we have a very active audience. Okay, so I'm just going through them. Okay, you highlighted them for me. Okay. Which course would you advise for linear algebra and calculus for a total beginner from a non-math background? So start with, I would say that if you want to get, okay, so you don't have to become exceptional at linear algebra and calculus to do machine learning. Not to say that those are not important. So what I'm saying is that start with the Can I type here? I'm not sure. Okay, probably can't. So go
You can
to
give.
the step. Huh?
You
Okay.
can type me in the private chat. I will post there. No issues.
Okay, awesome. So I'm just going to share a link, ml-class.org. So go to the machine learning course from Stanford on Coursera. It starts assuming that you don't have any um, intensive mathematical background. So it will start from, and it will, so Professor Andrew is a great teacher. So you'll be able to understand, matrix multiplication, basic linear algebra, and calculus from that course itself, and you can build up on that knowledge more from yourself later on. But I believe there are some. If you do want to check out more of the mathematics concept of machine learning, in addition to those courses, you can check out the deep learning book written by Joshua Bengio and two other people. I'm not sure I have it right now, but it's called the Deep Learning Book. So you can Google it later on and find it. But if you want to learn more concept, you just need to understand basics of linear algebra and calculus and just build up on some, uh, you know, chain rule and derivatives, and you'll be able to do well in it. So you don't have to become super good at it for starting out in machine learning. So okay, so let me take another question. So, will a course in applied statistics cover math included in AI and data science? Well, not explicitly, I would say that your professors won't be saying that this is used in machine learning, but if you parallelly learn machine learning at the same time, you'll realize which parts of the course that you're doing at your university or from an online course, I'm not sure, you'll be able to realize, oh, okay, this was used in my algorithm some time ago. My instructor just hinted upon it earlier, but I'm able to understand it more deeply now. So you'll be able to draw parallels, is what I would say. But it will help you. So taking a course in applied statistics will help you. Any tips to work on communication skills for presentation in front of stakeholders? Yes, so I would say that keep it short. So for documentation, more is less. For presentation, less is more. So in presentation, you want to be able to talk more and show less because people, understand more from what you're speaking than from what you're showing. And it's a skill. So you learn it better every time you do it. So I would just say that keep doing it as much as you can, and you'll become better at it. If you take part in community projects, you'll become at it much faster because you'll be doing a lot of presentations, sometimes several in 1 week. Please suggest book for math for beginners or any video content. Again, I'm not sure that I'm not the best person to ask this, but because I personally never learned from books. But okay, I should probably prepare this better next time. But I'm not. So again, for math, I would say that you don't need to find a book to learn it. You can just start with an online course and find a supplementary learning material either on. Okay, so I know that there is this. Okay. Oh, okay, good. I found it. So okay, I'm going to give something to Gaurav here so he can give it to you. So this book that I'm sharing right now is useful because it has a lot of core mathematical concepts of machine learning explained in a very good way. So make sure to check that out. And there's also a lot of resources. If you go to, so a lot of machine learning courses these days spend some good time in the math. So you'll be fine with that. Best data set example chosen to explain easy to, okay, best data set example chosen to explain easy to understand most. Okay, thank you for that. Um, thank you, Vivek. Okay, let me follow on more questions. So anybody's beginner like me wants to connect for net. Okay, so can you explain about data sets in upcoming news sessions? I'm not sure what you mean by that, but okay, I'm really not sure what you mean by that, but um, so let's just move on. Again, if you have, okay, by the way, if I can't answer all the questions right now, you can find me on LinkedIn. I hope that people from DevStreet can put my LinkedIn in the comments, not the comment, the description. So if someone wants to reach out, they can. I got the Pokemon. Okay, so if you can share how you actually took up Kaggle problems initially, what was your approach with solving? Okay, so personal note, I don't like Kaggle for Kaggle competitions because I'm more of a collaborative person than I'm more of a competition person. but that's just me. So I like Kaggle for the public data sets that they provide with good documentation and easy to actually SSH them locally if you want to use them. But I know a lot of people who work on Kaggle challenges, and a good advice that they always have is that learn from others' notebooks. So don't just work on yourself, on your own notebook, just throughout the competition. See what other people are doing, try to understand it, and only after you understand it well, try to improve it. More so than just trying to win the competition. So you see what I mean? How to join the deep learning AI community? Okay, so you can go to deeplearning.ai/events, and over there you'll find a very easy step to approach the events marketing team from Deep Learning AI to sort of say that you're interested in becoming a Deep Learning AI ambassador. Of course, you'll need some previous event planning experience, but not extensive. And you'll find a lot of support from other Deep Learning AI ambassadors to help you get started. So all the best in that when you get started in that. I'm looking forward to that. Okay, so let's see, what more do we have right now? I heard about transformers. Okay, yeah. Some of these topics that I covered were advanced, and we can definitely tackle more of them later on in a future conference event for sure. Um, okay, so I'll just paste the link again. I'll just give the link again for the in private chat, so you can so Gaurav can share it, so you guys can find this here. So yeah, I believe there's an interesting quiz for you guys now. So I'll hand it back to Gaurav to start with the quiz.
Thank you, Ramansh. Okay, so we are going to start the quiz, guys. Somil will handle that.
Hello guys, welcome. Now moving forward, I have prepared a quiz for you all, and we even have a surprise waiting for you. We have prepared digital certificates, and we will be asking your details for the certificate shortly. So there is a link posted in the chat by Gaurav. You can just go to that link.
Somil, you can share your screen.
Yeah, I'm sharing. Can you see my screen?
Just a second, I'm adding it. Okay, guys, join as fast as possible. We'll start it soon. We have 5 participants till now. We'll wait for another 1 minute and we'll start it. Join us up, guys. If you wish, you can join later on. No problem. The link will be open to you all. So, Somil, you can start there.
Okay.
So we have Harshit Kandu at the first rank. On second, we have Saloni. Still few questions are left for Saloni. Harshit has completed his test. Hurry up, guys. Namrata Sharma on the third, Ovia on the fourth, Pranav Tripathi on the fifth, Aditya on the sixth. Let's power up. The participants who are on the first five, please share your email ID along with your name so that we could send you the certificate through mail.
I think I can refresh the page once. Like, I think it's not updated.
Okay, fine. You can refresh it once.
Yeah,
Okay.
yeah. I think this is a refreshed
So,
one.
so is it the final list, Somil?
Yeah.
Ovi on the first, Pranav on the second, Saloni on the third, Harshit on the fourth, and Namrata on the fifth. I appreciate Vivek and another members. You have also done a lot. And okay, so participant in the first five, you can share your email ID along with your name. You can comment it in the chat box. Ovia, Pranav, Saloni, Harshit, and Namrata. You can comment your email ID along with your name in the chat box. So we have Namrata here, Pranav here, Saloni, Harshit, and Ovia. You can comment in the chat box so that we could know your email ID along with your name. We have a certification for the top five participants. I appreciate Nihal, Shubham, Prajakta, Tejashwini, Kelly, Aishwarya, Aditya, and Vivek. Nice participation, guys. Since we have certification for just five of you for the top five participants, but I think I will give a consolation prize for you all. Okay, fine. Somil, you can end the screen sharing.
Yeah.
Now I would request Rahul to tell the votes for thanks.
Yeah, bro. Yeah.
Yeah.
Thank you to all of you for attending this event. Hope you have learned a lot from this event, and I hope that it would help you in the future. Now the time has come to wind up this event. So thank you and have a nice day.
Thank you, Ramansh, for having sharing
Thank
your
you.
all the
Have a great
perspectives to
day,
the
everyone.
student, and we have got a lot of comments so that you can have another session with us on the transformer and other content. We wish to see you again with the day street, and thank you a lot. Thanks, guys,
Of
for
course.
joining. We'll end up the session. Thank you.